Redox. Redox are basically type of chemical changes. Redox is a combined term of reduction and oxidation. Coupled reactions, simultaneous reactions. Mean kind of chemical changes that if reduction is occurring, then oxidation is must, and if oxidation is taking place, then reduction is must. They goes together. Okay. Now there are various ways by which redox takes place. Various type of ways to explain them. Okay. Various cases like gain of oxygen is oxidation, loss of electron is oxidation, gain of oxidation state is oxidation, a loss of hydrogen is oxidation. So there are various ways by which the redox occurs. The oxidation takes place. Same goes for reduction, like loss of oxygen, gain of electrons, loss in oxidation state, gain of hydrogen. Different type of mechanisms are there for redox to take place, redox reactions. And redox reactions are extremely important, basic reactions needed for our electrochemical industries. Electrochemical industries involves electrolysis, and electrolysis needs electrolytic cells. So we can prepare many chemicals, we can extract metals, and we can refine metals, we can electroplate. But the basic chemical reaction that is involved behind is reduction and oxidation. Similarly, electrochemical cells, all these batteries, they involve basically redox reactions. Like the basic voltaic cell involve redox reaction. And all these advanced cells, even the hybrid batteries, they involve reduction and oxidation taking place at their electrodes. So it is the basic skill needed, and topic actually covers the foundation courses or syllabus for GCO levels, for IGCSE, for Edexcel, for American High School, and many equivalent exam system at this level. And remember, this topic of redox will cover in a way that you are having a strong foundation, strong basic foundation for your electrochemistry, both in O levels and A levels. And even the redox reaction will help you understand how the metals are extracted from their ores. Okay, and both in A levels and both in O levels, you need this basic skill of redox. We'll deal each case in a separate fashion. I mean, each case will be described separately. They have their relevant equation, description, and all that. So, based on different cases, we'll deal with the first one in terms of oxygen. We call it as case of oxygen.
मैं मिटाते हुए नहीं बोलता, जब हमने मिटाना शुरू करना है ना, वो आपने समझना है, वो कट जाना है.
बिल्कुल सही बात है.
तो उसको आपने कहना है कि लेट्स मूव ऑन टू.
So we said oxidation is gain of oxygen, then reduction is loss of oxygen. I'll take examples. Like iron oxide, Fe2O3, is basically the major ore of iron. We call it as hematite. And when this iron ore is heated with carbon inside the blast furnace, carbon turns to carbon monoxide because of lesser oxygen. Reacting together, a large amount of iron is produced and a waste product is carbon dioxide. You'll notice that iron oxide has changed to iron, and there is what? Loss of oxygen. And your definition says the loss of oxygen is reduced, reduction. So carbon monoxide has changed to carbon dioxide, and it is gain of oxygen. And definition says gain of oxygen is what? That is oxidized. Now if one substance is reduced, other is oxidized. If it is oxidized, it is reduced. So it means they are simultaneous or coupled reaction. If it is reduced, the partner is oxidized. So this is oxidizing agent. And if it is oxidized, the partner is, this one is reduced. So it is a reducing agent. So redox reaction is, it means basically between a reducing agent and a oxidizing agent. And reaction has produced what? In the blast furnace, when this is done, iron is obtained, 96% purity iron, which is later on refined. So the case of oxygen is basically one substance losing oxygen and other gaining in oxygen. This is one best example of extraction of metals and how the redox reaction, the chemical reduction method, look at the carbon monoxide acting as a reducing agent, is used in preparing metals or extracting metals from their ores. I mean, this was an impure form of the metal, iron oxide, and this is the pure metal, 96% pure. And most primitive idea from ancient time, man has learned basically prehistoric time, that how iron ores can be changed to iron by heating in carbon. Today, in terms we describe, this is redox, because loss oxygen, this is gain oxygen. And same mechanism is used, millions and millions of tons of iron is prepared in the blast furnaces around the world using this mechanism. We can take another example. We have copper oxide, black powdered, and when it is reacted with hydrogen gas, heated together, the sign for heat, redox will again take place, and you'll find out black copper oxide has changed to reddish pink copper, and hydrogen gas has turned to hydrogen oxide, steam or water. Now black copper oxide turned to reddish pink copper. It means copper metal is extracted from its ore by redox mechanism, and again the same copper oxide has turned to pure copper by what? Loss of oxygen. And loss of oxygen means reduced. When it is reduced, it is an oxidizing agent. And hydrogen has changed itself to hydrogen oxide by gaining oxygen. Gain of oxygen. And gain of oxygen, we said, definition says oxidation. And it is oxidized. Oxidation occurs, so it means it's a reducing agent. Another term you can use for reducing agent is reductant. So hydrogen basically is reductant, and copper oxide has been reduced, so it's an oxidizing agent. You call it as oxidant. Couple reaction, this is reduced, this is oxidized. It is oxidized, it is reduced. So redox basically has helped us to get pure metals from their ore. Okay. So in terms of oxygen, most primitive idea to explain redox, there is the loss of oxygen and gain of oxygen. This is one case. Okay. Even another example, we have zinc in nature in the form of ZnS. This is zinc ore. We heat it in air, and as a result, we'll find out that it has turned to zinc oxide, and the gas sulfur dioxide is given off. And once you have the oxide ore, you can again carry out redox. Heat it with carbon, and you'll find out it has turned to pure zinc, and carbon has turned to carbon monoxide. So again, same thing, loss of oxygen and gain of oxygen. So redox in terms of oxygen, basic idea, most primitive idea. And this is the first case of redox that we close here in terms of oxygen.